A.REI.3, this is Algebra, Reasoning with Equations and Inequalities, Part 3, Video 4, Solving Equations with Variables on Both Sides. We have one new term in our journal. It's called identity. I'd like you to pause the video and define that word. All right, today we are extending the ideas from the previous videos on solving one-step equations, two-step equations, and multi-step equations. Now we're going to look at equations that have the variable on both sides of the equal sign. So there are three things that are going to occur. You're going to have one solution, the identity, which you just defined, and something called no solution. So I picked out three problems that will show each of those. The one solution is the one you're going to run into most often. These are the ones where you find out what the variable actually is when it's only one particular value and only one value. So let's combine like terms. Start off drawing the wall. Looking for like terms on either side that you can put together, and I notice that on the left side we are not able to put these items together, 8 and 4m, because one is a constant and one is a coefficient with a variable. So same thing on the right side. Now we're going to have to just swing things around to combine them, bringing them to the other side of the wall. So you have four options. You can either combine the 8 with the -7. You could bring the 4m over first with the 9m. Maybe you wanted to bring the 9m to the left with the 4m, or the -7 over to the left with the 8. Whatever choice you make, in the end, you are going to come up with the same answer if you do the mathematics correctly. I'm just going to look at the m variable first, and I think the easiest thing for me to do would be to get rid of the 4m and bring it over to the right. And we would have to subtract it. Okay, so it's gone on the left. We have 8 equaling 5m. 9m minus 4m is 5m, and I'm left with my -7. And here we are, we're at our two-step equation from one of our previous sections, and just knock this out. So m is equal to only one value, which is 3. 3 is the only number on the number line, the only integer that will work in this particular equation. So you can go back into the original problem and substitute in your 3 wherever you see an m. So I have one on the left and I have one on the right. And if I want to check real quick, I have 8 added to 12 equaling 27 subtracted by 7. So 8 added to 12 is 20, and 27 subtracted by 7 is also 20, so this checks out. So 3 is the value of m. All right, I picked another situation where we're going to come up with multiple answers, I guess you would say, all answers, all real numbers. We call it the identity. And as I solve this equation and combine all my like terms at the end, you're going to see what I'm talking about. So let's quickly use our distributive property and solve this equation. Now, I could stop here. I would prefer it if you stopped here. If you see that the left side is equal to the right side, it won't matter what value you pick off the number line to substitute in for G, because when I multiply it by 6 and add it to 4, it will always be equal to the same number multiplied by 6 and added to 4. You know, you pick a number and check it, they're all going to work. I'm going to continue the process because maybe you don't see it right now. I'm going to keep adding, or not adding, but putting my like terms together. So let's get my G's together. So they're gone on the left, and I'm left with 4. And they are also now gone on the right, so I'm equal to 4. And here I see that 4 is equal to 4, and that's always the case. So whenever you have the left term equal to the right term at the very end of your solving, you've noticed that it's always going to be true. So in this case, the answer would be identity, also known as all real numbers, and every number from the number line that you plug in should work. The third thing that could occur is called no solution. Now, there just might be a random equation that was set up that really makes no sense. There isn't a value of C that is going to work no matter what it is. So how is that going to look after we combine our like terms? Let's put these two together, like terms. We're going to get a negative 8C. I'm going to stick with the same process I've been doing. I've been trying to get rid of my variables first. So if I have a negative 8C on the left, to get rid of it, I'm going to add 8C. There it is, add 8C. And then I also have to add 8C on the right. Here it is. And let's check it out. So these are gone on the left, and these are gone on the right, and I have now 1 equaling 3, and that's a false statement. 1 is not equal to 3. So in the final answer, if you continue the process, if you couldn't have seen it on this line that has the check mark, continue the process until you've combined as many terms as possible, and then look at your final equation and see if it even makes sense. And 1 equal to 3 does not make sense, so we call this no solution. There aren't any numbers that will ever work. Pause the video and solve this problem. It says find the perimeter of the square. That's important, it's a square. And we are back. Well, a couple things about a square are important. I know that all of the sides are equal to each other, but it says find the perimeter, so I'm going to set up a sum problem, a problem that involves addition, and I'm betting it's, you know, trying to combine all the like terms to see what your expression is. So taking the value on the right leg here, the right leg of the square, it says 8x minus 10. And there are 2 of them. So I'm going to take the first leg and I'm going to add it to the second leg, which is 8x minus 10. And then I have 2 other legs called 6x. So I'm going to add the third leg, and then I'm going to add the fourth leg. And I think the standard wants you to combine like terms and see what your final expression is for the perimeter. So we have all of our x's. Let's put those together. 8 and 8 are 16. 6 and 6 are 12. So 16 and 12. We have 28 x's. And then let's get a different color, different shape. I have negative 10 and negative 10 for constants. Put those together, we get negative 20. Okay, so If they're asking for the perimeter, we know that the perimeter of the figure using the terms would be the expression of 28x minus 20. Now I'm going to take this problem a step further, and I'm going to actually figure out what the value of x is to find out what the perimeter is in terms of units. Now they didn't give me units, but I'm going to try to figure out what that unit might be. Let's branch this off. So what I know about a square is that the two sides are equal to each other. So if those two sides are equal to each other, let's combine like terms. So let's subtract 8x from both sides. So negative 10 is equal to negative 2x. So x should be equal to positive 5. Now, if I were to take that positive 5 and substitute it into my two expressions on the square, so I have 6 multiplied by 5, 8 multiplied by 5. So we're going to have 6 multiplied by 5 is 30, 8 times 5 is 40, minus 10, which is also 30. So we can say the perimeter of the square has 30s across the segments. So that would be 120 units. I don't know what the measurement is, if we're in feet or yards or centimeters. It doesn't tell me. So let's just call it 120 units. In your journals, please define the new word on page 2 of the flip chart, that is the identity, and write a few sentences on what you learned from the video, and put a star or some type of notation next to the problem that you might not understand if something was confusing here. Bring those questions back to class and let's talk about them.